Hi, and welcome to Advent of Code. It's day 5, and let's read the task. So, you take the boat, you find the gardener, the water source. Island is the water source. You point out that Snow Island isn't receiving any water. We had to stop the water because we are out of sand to filter it with. Okay. Can't make snow with dirty water. Yes, thank you. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks, oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. Ooh, it grows and grows. The latest Almanac just arrived, and we're having trouble making sense of it. The Almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed. So we have seeds, we have soil, we have fertilizer to use with each kind of soil, and what type of water to use with each kind of fertilizer, and so on. So we have seed, soil, fertilizer, and so on. All of them are identified with a number, but numbers are reused by each category. That is, soil 123 and fertilizer 123 aren't necessarily related to each other. Okay, so we have this example. We have 4 kinds of seeds. We have seed to soil map, which I believe just maps a seed to a soil to fertilizer map. Why do you have 3 numbers in here? I can understand this, but why do you have 3 numbers? Fertilizer to water map. And now we have 4 numbers. Water to light map. Okay. Light to temperature map. Okay. Temperature to humidity map. Humidity to location map. So we have seeds, soil, fertilizer, water, light, temperature, and humidity. And location. Wow. The almanac starts by listing which seeds need to be planted. Seeds 79, 14, 55, and 13. The rest of the almanac contains a list of maps, which describe how to convert numbers from a source category to a destination category. That is, the section that starts with seed to soil map describes how to convert a seed number into a soil number. Okay. Rather than list every source number and its corresponding destinations number one by one, the map describes entire ranges of numbers. Okay. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Oh, okay. So, the start of the source is 50, the start of the destination, the end. So this is the destination range start, this is the source range start, and this is the range length. So 98 corresponds to 50 in the destination range, 99 corresponds to 51, and 100 corresponds to 52. Okay. And this range... Whoa. Okay, let's read it. So we have just But why we had this kind of length? The first line has, okay. Only two values. It does not include 100. Okay. The destination range is the same length, but it starts at 50, so its two values are 50 and 51. Okay. With that information, you know that the seed number 98 corresponds to soil number 50, and that the seed number 99 corresponds to soil number 51. Oh, okay. So this is also a mapping, and it maps 48 numbers starting from 50 into 52 in the destination codomain. Yeah. The second line means that the source range starts at 50. Okay. So it's from 52 up to 99 in the destination range, right? Yeah, sounds good. Okay. Any source numbers that aren't mapped correspond to the same destination number. What? So by default, you map to the same number, and some ranges are overridden with another mapping. Okay. So the entire list of seed numbers and their corresponding soil numbers looks like this. From 0 to 1 to 50 to 49, and at 50 it becomes remapped to 52, 53, and so on until 99. What happens at 100? Oh, I'm wondering if this mapping is one-to-one or not. With this map, you can look at the soil number required for each initial seed number. 79 corresponds to 81, 14 to 14, 55 to 57, 13 to 13, okay. The gardener and his team want to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. You'll need to convert each seed number through other categories until you can find its corresponding location number. Okay, in this example, the corresponding types are seed 79, soil 81, fertilizer. Oh wow. Okay, so here I need to know where to plant the seed 79, okay? Is that true? Okay, and that maps to 79. Let's just copy this example. Up. Oh. Okay. Okay, let's create a directory. 5. Let's create an example txt. Okay, we have it here now. So seed 79, it goes into this range, so it becomes remapped to +2. So the soil is 81. Soil 81 maps into what? Is there any range that it can go into? No. So it maps to fertilizer 81. Fertilizer 81 maps to water. Is it 81 again? Yeah. Water 81 maps to. It goes into this range, so it maps to -7, and that is 81 minus 7, 74. Light 74. Light 74 maps into. Does it go into this range? Yeah, it does. So it's +4, and +4 means 74 plus 4, 78. Temperature is 78. Humidity. Oh, so where's the location? Oh, I missed that. Yeah. Temperature to humidity map. And so what was temperature 78? Temperature to humidity. It maps to 78, and that maps to location +4. So 78 plus 82 means +4. Yeah. Okay. Yeah. So we have location 82, 43, 86, and location 35. And the lowest location is 35. So what is the lowest location number that corresponds to any of the initial seed numbers? Okay. Let's get also our input. Humidity to location, temperature to humidity, light to temperature map, water to light. Okay. Okay, so let's think about the solution. So first of all, we have humidity to location map. We have temperature to humidity map, light to temperature. So this is basically a linear chain of mappings. So we don't have any backward mappings. We don't have any forks in that dependency graph. It's just there is a chain of mappings, and you just go through it. Okay, the numbers can get pretty big, so having bitmaps could help, but it's not actually helpful. Humidity to location map. So yeah, my intuition tells me that it's really a kind of a binary search. You have some segments, and these segments are ordered, source segments, and then you can binary search over them. And then you just need to transform the seeds through this chain of transformation, and then the lowest number in the end will give you the result. Yeah, well, that sounds like a plan. Let's do that. So, first of all, cabal init. Yeah, executable. Existing files. What do you mean? No. Whatever. 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 Okay. Now I do stack init, and yeah, stack run. It works. Yeah. Finally, I can create a Haskell project in less than 15 minutes. Yeah. Now, so app main. So subtask number 1, read the file and make sense of it. In any case, we start with reading the input and parsing it. So that will be read file fpath. What's fpath? Fpath comes from the process arguments, and to do that, let's read them in. And let's import modified system.environment as env, and then we print the solution, which is this. Then let's create the solution. And let's say that we have some input and the solution is undefined. And I don't know yet what will be the type of the initial structure, because we will be parsing it, and I will have to define the best representation for this. But I do know that the result will be int. So, type. Let's call it Almanac. And it's undefined. Would you guess that? Almanac. The second thing that we need is parsing. So we need to take in a huge string and we need to turn it into an almanac. Almanac. And its implementation is again undefined. So okay, this looks good. Yeah. Now let's start parsing. So we have input and we have example. Yeah. So there is the seeds part. There is a seed to soil map. We have to skip the empty lines, and we have to know what the maps are. Okay, so fertilizer, water to light, light to temperature map, temperature to humidity map. Okay. So we have the string. It's definitely a good idea to break it into lines immediately, and also to filter and filter out empty lines. And that can be done like filter. Do I have any is empty in list? Okay. Was it something like yeah, the nonsensical Haskell names again. So if we want to check that the list is not is empty, it's called null. Why? I don't know. Just to mess with you. Okay, so let's split it into lines. Then let's filter by not null. And after that we have a list of lines. during the parsing, we can be in several different states. So, maybe I can actually say that the almanac is a structure of almanac. Okay. So it starts with seeds, and these are ints. Yep, looks weird enough to be unique. So elm seed to soil. What will this be? I have this urge to use the universal hammer of Haskell data structures, the map. It's ordered, it's fast to search, it's fast to use, it's right there in containers, but is it the right urge in this case? On the other hand, why not? I have an ordered list of segments. Segments have a start and a length. If I just search the closest lesser start than what I need, and then I check if it goes into this length, then I should be fine, I guess. Another approach is to treat the end of a source range as a start of an unmapped range. Does it make sense? But yeah, I don't really see why I need that. Okay, so yeah, maps it is, because yeah, data map is map, and yeah, let's say that this maps what? A range. Let's define type range, and let's say that this it has a start and a length. Should I do that as a structure too? Well, this could make it slightly more readable, but I still need these values also to be also ordered, so they will have to be ordered by the index of the start. Okay, that's why I just keep it a tuple, and I just keep in my head that start length, it's this way. What was this weird Haskell doc syntax? Interesting. Was no. Okay, that is good enough. Yeah. So it maps a range into a delta. So that's the number that we have to shift this range into or by. So it maps a range into a delta. And yeah, that sounds good enough. And then we have a soil to fertilizer map. Soil to fertilizer. That is pretty long. Range delta. Do I need to have commas in here? Oh yeah, I need, yeah. And then I have fertilizer to water map range delta. I need a comma here. Then I need water to light. Again, it's a map of range delta. And then I need light to temperature. Okay. I am abbreviating this. Map range delta. And temperature to humidity. Temp to humid. Map range delta. And then humidity to location map. Humid map range delta. Would it be better to wrap this in new types to be able to distinguish this? No, it's too much ceremony for this case. Okay. And then what do I need? I need to get a location for seed map. I need to map that. Oh, yeah. It's not. That's a part of the solution. It's not part of the parsing. Okay. Should I do it all at once? But do I have to? Oh, that's why you have empty lines. That's why you have empty lines. It's a hint. You can actually not filter them out. You can split by empty lines. And that looks like split at. No. Break. No. Span. What does span do? If I remember correctly, it was somehow similar to break. So span is like a pair of take while and drop while. Okay, yeah. Oh yeah, it's exactly what it says. Okay, so if we have lines and we want to split by empty lines, 1, 2, A, B, so lines. Did Haskell get? No, he didn't. I remember that there was a third-party module that that would give you tools to split a list by in different ways. So basically you could split on something, and you can split by a predicate. Should I re-implement that quickly, or should I just go to the cabal file and have it here? But I remember that the implementation was pretty easy. It was just some kind of unfold with spanning it into, with continuously spanning it, and then either continuing or do I want to do that? No, not really. Okay, so my dependencies. Let's add this left pod, split in here, and then we can import things from list split. By the way, if I used a sequence, would I get something like this out of the box? Split at take chunks of. No, that's not what I need. Split at a given position into two parts. No, that's not what I need. No, not really. Scans. Faults transformations. Okay, so let's just bring in the split and let's see how it goes. So it's been installed. Yeah, now we have the parsing error. And now import qualified data list. I'm importing the data list, and I'm importing the data list split as well, and I have them in the same namespace. That's a neat tweak that you have with Haskell imports. So it merges the namespaces, and if you have conflicts, then it's your fault. Okay, now I need to split Yep. And let's try that live. And I need to split on. Yeah, I can test for equality with an empty line. So if I do ls and then I do else split on an empty line, ls, I get nothing. Why? Does it take a subsequence? Wow. Okay. That is actually more generic, and that can be useful. But it's a bit unexpected, I would say. Okay. parseSection. So when I split it, I have these sections. And then what do I do? Yeah, I really wish Haskell had some kind of a default trait. Maybe Haskell default type class, for example. Oh yeah, Data.Default. Okay, yeah. And this is another package. Yeah. Does it implement defaults for maps? It does. Okay. Then I don't care. Let's bring another package. Data.Default. Now, import qualified data default as def. And also I want to bring in what? Class default. Do I want to bring it in? Maybe, I don't know. And also I do not even have data map available by default. Wow. So let's bring in containers. And now okay, good. So now what do I want to do? Can I do deriving default? Not in scope. Should I do it like this? Okay. Is it happy now? Cannot make a derived instance. Default is not a stock derivable class. What does stock derivable means? Are there any examples of deriving a default? Oh, okay. Okay. Let's remember how to derive things. Let's remember how to implement instances. So, instance default almanac. Where was it? Yeah, default is equal to well, what do I have to implement? Is it always magically auto-implemented? How do I use this? Okay. Value. Oh, you defined it manually. Maybe someone has a better solution? Okay. That's where Rust is so much better. Okay, let's just define it. emptyAlmanac is almanac that consists of empty elm seeds. It consists of seed to soil is empty, elm soil to fert. Yeah, it's map empty, it's map empty, alm fertilizer to water is empty, water to light empty, light to temp empty. I'm starting to like that idea of disambiguating the indexes, but uh, I want this idea with a twist. So Haskell enum to number. Can I do that? Bounded. Okay. Class enum. Oh, no, that's not an enum that I had in mind. Data enum to number. That's what I want to do. Derive an enum. Okay. That sounds good. Yeah, actually. So, I want to say that it's called category. Kind is overloaded, sort. Data what? Yeah, that sounds good. So data, so what? And what is either a seed, a soil, a fertilizer, a what was the next one? Fertilizer, water, or light, or temperature, or humidity, or location. And if I say deriving enum, what do I get in return? My lord. Yeah. And now that's the thing. Yeah. It looks like this was the perfect task to just make typing as uncomfortable as possible, because I don't see a good way to type all of that. But okay, let's skip that for now. Let's just do some maps. And yeah, that sounds good. So let's just finish this boilerplate, and let's stop shaving yucks. Let's just solve it for now, and let's maybe do a quick improvement to this code later. So human location is also empty at the moment, and that's how it ends. Okay. Somebody said that Haskell is less that Java is so verbose and Haskell is so not verbose, and yeah, and here I still have to write it twice. Okay, I'm just running at this point. Okay, so parsing. So we have our input, and I'm splitting input into lines. I am splitting it on empty lines, and then I map parseSection, and then what do I do? I am concatenating it, all of the parsed parts. And concat. Yeah, that's exactly what I want. I am concatenating it, and I have to say that Almanac is an instance of a monoid. That will bite me, definitely. On the other hand, why not? Okay, I'm just doing it for... Okay, it's my code. It's what I can do what I want. Yeah. Mconcat of what? Almanacs. And I say that does it have a name? I want the information about a monoid. Okay, it must have oh, okay, so it can be defined via mappend, I think. Minimal is empty. Okay. XY. And I say that oh, okay. X, Y, and I say this is an almanac where any non-empty sections override okay, sometimes you just have to do it, yeah. Okay, and does Haskell support record puns? Haskell record puns. Name field puns. Okay. And what does it do exactly? You can, instead of this, you can say just this. Okay. Let's just do it quickly. Alm sits x. Oh, alternative. It's usually control monad. Do I not even have it? Haskell alternative and MonadPlus. So what's MonadPlus? Please remind me quickly. So empty or something is something. Something or empty is m plus, m0 and m plus something is something. Okay. Instance monad. Ooh. Okay, where do I get my MonadPlus? The precise rules of MonadPlus are not agreed upon. Wow, such Haskell, much precision. It's in base. But I have to import control monad to get it, right? Right? MonadPlus. Okay, that's what I want, yeah. And let's just quickly verify that it works for maps. So m plus m empty. I also have to import map. Yeah. M plus m empty and m empty. it doesn't know what is the type of the key. Whatever. M from list. And let's say 8 to 1. But is there no instance for maps? Of course, there are not. So many abstractions. None of them are useful. Okay, let's just do that manually, because that is just... doesn't make any sense. Yeah. So, usually it's the second one, unless if null alm seeds x, then no, it's the other way. Else alm seeds y. Seed to soil. If null seed to soil y, then seed to soil x, else seed to soil y. I really don't like all of this boilerplate. What was that? So the first one becomes alm soil to seed to soil. It gets replaced to soil to fertilizer. Is that correct? Yeah. And this one alm fert to water. Vim, please. How do I say it? Vim, please. And now let's replace it here to elm water to light. And let's remove that very carefully. The next one is light to temp. I don't have alt left in this mode. Does it support Emacs like shortcuts? So if I press Ctrl B, what just happened? If I press Ctrl F, okay, it's very peculiar. Yeah, I have forgotten about every detail of Vim at this point. Light to what? To temp. Yeah, that's just taken so much time just to just to parse it. It's tedious. I wish I did this in a dynamic language. Well, I could have had a map of just strings to maps. And maybe that could have been better. Did I change all of that right? So humidity to location, yeah. What's on here? Light to temp. Do you like it now? Oh, I have to fix it everywhere. Is it better now? What does that even mean? Yeah, that must be called solve1, where parseSection is undefined. Oh, right. Yeah, so if you look at the definition of the monoid, it is defined on something which is itself a constructor type. No. Okay, what's on then? No instance for semigroup almanac. It must be a semigroup. What's a semigroup? Oh, it's something concatenable. Okay, so you do not say mappend in the monoid itself. You say that it's an instance of a semigroup almanac where mappend. Okay, let's just move it here. Does it work? Okay, let's say that this way. And does it like it now? I think it does. Yeah, that's okay. Yeah. So, parseSection. We have the header and the mapping. And in case, and this is a list, of course. Yeah. So the header is the first element of the list, and the mapping is the rest of the lines of the section. So case header off. In case it's sits. Oh, yeah, it doesn't work this way. Yeah, okay, let's just say that the first line is always the SID part, and all the others will be parsed after that. Okay. Okay, let's just move that out. Sits and the rest is equal to split input. Okay. Yeah, it's always bad to start writing this before I know what I actually want to write here. Okay, so now what do I need? I need to parse the section with yeah, and this is actually a pretty bad naming. Lines. So even better, I can split input into the first line and the rest of lines. Then I can say that sections is list split on an empty line, and I split map lines. Then I need to parse seeds and it will be undefined for now. And then I need to define how I parse sections. And this looks like map. Wow, I really need to be lazier, because I try to do it cleanly, and it takes me a lot of time. Find, and then I have, wow, that is really tedious. Soil to fertilizer map. Then I have fertilizer to water map, and then I have water to light map. Is that it? Yeah. And then I have, not this one, water to light to temperature map, to temperature map. Not df, dt. Yeah. And then I have temperature to humidity map. Then I have humidity to location map. Humidity to location map. Okay, good. Yeah. Then otherwise, let's just bail out with an error that tells unknown section show header. Okay. Now what? So now we have sections, and this now I can actually do so. I start with the parsed sits, and I apply that to mconcat of mapping of parseSection to mapline. Is it maplines? Is it? Oh, it's sections. Yeah, right. I have already used that name. Okay, and that should produce section. That should produce an almanac. What? Why do you call it section? Okay, let's just move it here. Yeah. Does it work? Kinda. Maplines. So, which type is maplines? It's a string. Oh, that was too early. Yeah. Right. parseSection. Defined but not used. Mapping. Okay. Why does it not work? Ah, because I need to use it in the undefined. Good. parseMapping. So, parseMapping takes a list of lines and returns a map from a range to a delta. parseMapping. Now let's implement it. And let's tell right away that this produces an almanac with alm seed to soil. No, it actually produces an emptyAlmanac. Yep, with overridden seed to soil mapping. Ooh, is there a better way to write this? parseSection mapping. Yeah, not so it obviously. Okay. It's just starting to get tired, I think. Yeah. No, I don't need commas in here. Why? Soil to fertilizer, and here it's emptyAlmanac with alm fertilizer to water. emptyAlmanac, water to light, parseSection. Oh, it must be parseMapping everywhere. It's not parseSection recursively. parseMapping, probably. Yeah. Now what? Let's take this. Yeah, it really is tedious enough for this to be generated somehow. Temperature to humidity is parseMapping mappend. Let Haskell, why do you take this useful name from me? Let's just rename it. So parseSection, data is taken by Haskell again. What do I call it? Table, whatever, and this becomes mapping. In case I have to shift it, I don't know, but that doesn't matter. So let's just remove parseMapping. I don't care about the spaces. emptyAlmanac humidity to location is a mapping. The last case is just, how is it not, I don't care that it's not exhaustive in this case. Yeah, one module loaded and it looks okay. Does parse work? Write file, example.txt. What do I get? Wait, what's parse? It's, yeah, it's not something standard. But in that case, what is happening exactly? Okay, please, just stop bothering me. Yeah? Reload. Pattern of type not matched. 69. Come on. Please. Come on. Okay, in any case, I do have to define some undefines. So I need to parse mapping. Okay, and that must be easy. So for each of the strings, I define, so I take the seg line segment line lines, and yeah, then I map segment lines with something that map read. Do I have split by white space in Haskell? Split it. Ah, it's called words, yeah, right. Because we are so generic, So, words of ln, words of the line, and let's measure that into 3 numbers. And the 3 numbers will be destination index, not index, start, source, start, and length. In that case, what do we add? We produce a tuple of a range to a delta, and the delta is just start minus SRC start, and the range is, what do I take? SRC start, and I keep the length in here. Okay, and the map returns a list of tuples of a range and a delta, and I can create a map from this, right? ParseMapping line plan. Let's take all of this out. Oh, did I not? Okay, let's just move it out and make it work. Yeah, of destination, otherwise error parseMapping line. Okay, and then what? Here gets replaced by parseMapping line, and this is partial, but I don't care about that. Yeah, and now let's parse. And do I get just nothing? Why? Okay. Which one? Oh, okay, it must be specified on the type itself. Okay. Finally, at least I get an error. So, error is called where 81 parseSection is empty. Huh. Okay, I also should have dropped another line here. It should be an empty line. Not that it will check, but it's still good to see. Okay, now let's parse again. Undefined, so something is not implemented. And yeah, that is the SID parsing. Okay, so we start with SID. Yeah, drop while else strip prefix SIDs. Then let's split it into words, and then let's map it with read. Is that it? Where do I get maybe in here? Okay. From just. Why do I always have to bring this exact imports in my Haskell program? From just and okay. Now we have from just. Now it should not complain, but it does complain. So strip prefix takes from what? Yeah. And it takes it from seed line, right? And that should return a maybe. From just is partial, but it's just a warning at the moment. Let's. Okay, I cannot reload. Why? Line 68. Seeds. What's wrong with it? What is the type of seeds? Any. Okay, yeah, it cannot infer its type, that's why it just defaults to some. Is it even Haskell? Is this just a weird dialect of TypeScript that I'm programming in? What is any? Okay, seeds. But I said it's a list of ints. What's wrong now? Oh, yeah. I see. It should be wrapped into an almanac to be able to seeds to be able to be mappended. Yeah. So good. Let's parse alm seeds. This finally it only took wow. Yeah, that's really a task that is supposed to punish you if you try to parse it too strictly and too cleanly. Wow, what a pile of crap. Yeah, okay. Yeah. Okay, let's just focus on the task. So now finally this marathon of parsing is finished, and let's just solve the task. So there is an almanac, and actually I can destructure it right here. Almanac, and let's say it's undefined for now. Record wildcards, yes please. Why do I have to do all of these ceremonies? Record wildcards. Could I just use a language where the batteries are included? Where I have sensible default types, where I have sensible structure construction, where I have record wildcards or any other kind of panning out of the box. But no, I use Haskell. Okay. So now we have the seeds, and we have to be able to search for a mapping, and that looks like another useful helper which I create here. So basically Okay, yeah. So map map is segments, mapRanges. Yeah, mapRanges. Map is ranges. So let's take a map of a from a range to a delta, and let's produce. Let's take an int. And let's produce an int. So let's say that map_ranges is equal. So we have a mapping. Everything is terrible. I don't care. So let's take a range map and let's take an index x, and now let's map it. So I have to look up the find max, find min. So what does find min do? Oh, it just gives you the global minimum of the map. And if I want to search for the smallest key, is it some kind of a lookup? Right. Yeah, I remember it right. There is a helper that lookups a less or equal key, right? Is that it? Yes. So it takes a key, it takes a map, and it returns a maybe a pair of key and a value. Yeah, that's what I'm looking for. So now, let's say it's still undefined, and let's just do this boilerplate. So case maybe what? Lookup less than or equal x in x0 in the range map, and that gives me either nothing or just a tuple of a segment start and a length of this segment. And that means what? In case it's nothing, I have to just return x. In case it is not nothing, it is just a tuple of a key and a value, delta. In that case, so range start length. Okay, now I have to check if x is in this range. Again, I'm having this urge to do some yolk shaving and enum. No, it's not like Python or Haskell ranges, no. I have to do it myself. And that means start is less than equal to x, and x is less than equal to start plus length not inclusive. Yeah, so it should be like this. And if this is true, then I must return x plus delta. Else I must just return x. Okay. Let's make this slightly more readable. I would say that this is from maybe of I apply all of this stuff to this function. And yeah, what I do, map range, if I got a start and a length, and if I got a delta, and I want to map some x, then the rest is this. Okay. Where did my then and else go? Did I remove it? Did I remove it accidentally? Okay. Yeah, it looks so. Map range. Okay. Does this work? From maybe. Why do I have to type this in? Shadows, the existing binding. Well, yes. That was a useful suggestion. Use maybe. And what do I do if I use maybe? I don't know, but should I care? Okay, reload. Let's say that I have the almanac, which looks like this. And let's say that I want to map with ranges. And I want to map with ranges what? Using, let's say, almanac soil to seed to soil from almanac, and I want to map 79. I get 81. That sounds good. And then I map soil to fertilizer 81, and then I map what was that? Fertilizer to something, water, and then I map the same number. Wait, why does control Y did that? Okay. And here I want to do water to light, and here I want to do light to temperature, and here I want to do temperature to humidity, and here I want to do humidity to... Oh, that's where it went wrong. Okay, in any case, it works, it does look valid. Okay, now, so, solving it. I have an almanac. And I have to do this ridiculous thing. Map with ranges, almanac, seed to soil. Okay, almanac seeds, and then oh yeah, I confuse all of that. So map with ranges alm soil to fertilizer, and then I can do map map with ranges almanac fertilizer to water, and then I can do map with ranges almanac water to anything else, to something else, and then I can again map light to temperature, and then I can again map temperature to humidity, and then I can again map with ranges. Yeah, thanks. And then the last step, I can do map with ranges, humidity to location, and that should give me well, okay, what's the type? Okay, what's the problem with this? Isn't alm seeds a list of ints? Okay, why? What? Okay. So when you map this, you have to actually take the smallest number out of all of this, and this can be done with minimum. Yeah, and this can be done with minimum. Let's reload. Let's verify that it works with the example. There is no such file. There is no such file. By the way, what do you do? Yeah, open file doesn't exist. 32. Is that even correct? 35. 35. Something is wrong. So, let's say that can I do it this way? Yep, I think so. So, how do I debug that? Not this add, but trace show. Okay, and here, let's go to the ranges. And let's say that we want to debug. Trace show. What do we have in there? Trace. What does it do? Takes the string. That's not what I want. That's not what I want. What I wanted is a kind of a probe that just takes a value, returns it, but also outputs it for tracing. Isn't it just trace? Oh, maybe it's trace ID. Trace ID. It works on strings. Trace show still takes an argument. Is there really nothing useful in here? Was it so hard? Okay. Wow, that gets ridiculously long. Okay. Okay. Let's proceed. Let's write the helper debug. Debug x. Debug. It must be a type that is able to be shown, and let's say that this is trace show x. And now let's go to the mapWithRanges and let's say that we want to debug this value. Reload. Not reload, but let's run it. Yeah, it's not exactly easy to understand what's going on here. Okay. You can use your maybe. Yeah. So, what's going on here? 42. Are the maps correct? Did I do something wrong with the maps? Parse. And let's look at the almanac. So alm seeds are like this. Seed to soil map. Yeah. So the range from 50 to 48 with delta 2. And yeah, it's this one. Okay, sounds good. To range, is this a destination? Minus 48. Yeah, that's correct. So 98 must map to 50 and 99 must map to 51. Yeah. Soil to fertilizer map. It has soil to fertilizer. So it has a range that starts at 0 and its length is 15. Wait, what? That really doesn't look right. And it has delta of 39. No, that really doesn't look right. Okay, yeah, that's where it went wrong, I guess. Oh, this stupid parsing. Okay. Let's just check quickly that margin also works like I think it works. Okay, and let's check the parsing now, because I have a strong suspicion that I just forgot to change my copy-pasted lines. Seed to soil map sounds good. Soil to fertilizer sounds good. Fertilizer to water sounds good. Water to light. Oh, light to temperature is empty somehow. How did it happen? Because yes, exactly, I forgot to do this mapping. Yeah. So let's pause. Let's look at Alm. I wish I could pretty print that from list non-empty list, from list non-empty list, from list non-empty list, and this is non-empty list, and this is non-empty list. Okay, good. Do I get the right result if I try to map with not map with ranges, but map almanac, map seed to location. So it takes an almanac and takes an int and produces an int. Map seed to location almanac. All of this, and what it does is basically map all this stuff. Yep, and here map seed to location, and here changes to the almanac. Yep. Couldn't match the expected type. But it does still take an int. Oh, yeah, right. Because... Okay. Module loaded. Alm seeds. Oh, okay, yeah, right. Now I need to use it as a function. Okay, let's parse it again. Let's map a seed to location, and the first seed is, what was that? using the Almanac, and this first seed was 79. It maps to and okay, 79, fertilizer 81, water 81, 74, 78, 78, location 82. That looks right. Seed 14. Okay, that's where it breaks. Soil 14. Yeah. Fertilizer 53. Yeah. Water 49. What's one with fertilizer to seed to soil, soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity, and humidity to location. Okay. Again, is there anything messed up in here? Water to light, yeah. Light to temperature, yeah. Temperature to humidity, yeah. Humidity to location, yeah. Soil to fertilizer, fertilizer to water, water to light, light to temperature, temperature to humidity, and humidity to location. Okay. And it goes on in water, seed 14, soil 14, fertilizer 53, and then it breaks in mapping of from fertilizer to water, right? And it breaks because 53 oh, less than, ah, crap. So the situation is I'm looking at I'm looking for 53.0 in a map that contains 53 with some length 8, with length 8, yeah. And what it does, it uses lookupLE, which does not find this mapping, because I should not look for 1 here. I actually should look for max bound in here to find all of the lengths that are smaller, all possible lengths for this X. Okay, let's check again. 43, is that correct? Yeah, it looks correct. Yeah, seed 55. It produces 80, good, and seed 13 produces 35. Okay, finally I have some confidence in this. 35, okay. Let's remove debug. Let's do run again. Let's run it on the input. Okay, that's a pretty serious number. And 1 hour 50 minutes in, we have the right answer.